Right. So let's sit down, relax, and we need to speak about, well, constraining a little bit the movement of our ship. Because right now we are free to go everywhere we want in our map, right? We can go left and right, we can go inside the track, outside the track, really up, really down. So we are free right now to do whatever we want. We need to constrain a little bit that movement. And then what I want to achieve is, let's look at what we have right now, right? We have our track and we have our ship. I assume that our ship should be at a certain height of the track, right? Almost like if it was hovering, right? Which is kind of the idea of the original Wipeout, right? This anti-gravity thing that you hover and then you move in this track. So I think that we're gonna have to have this, almost like this distance, right? Because given that we have the ship position and the track base, we have to always consider the distance from the track base. Remember that we have sections in our track, and each section has faces. Some of these faces, there is a little flag that says if that is a base of the track. So we might have to consider that as well, right? The distance between the track base and the ship position. But we're going to have to do some math here, because which face are we considering the height, right? This height distance from the track. We're going to have to think about that. But given that we have this distance, I think what we are really interested in is applying a couple of forces in our ship, right? After we decide where we should position that ship, we should have these two forces, a force up and a force down. So we might want to consider, right, leaving this ship hovering at a certain height. And if we go too much up, we have to apply a force down. And if we go down, or if we're trying to dive into the track, right, too close to the track, we have to apply this force up. So down and up, we're going to have to find the magnitude of these forces that we're going to have to apply to kind of keep the ship hovering at this position right here. So now that we know we're going to have these two forces, right? Beside all other forces like acceleration, thrust, all these forces, they are still being applied. We're just going to have to add one more force vector, right? Or two more force vectors to our ship. One which I'm calling force up, which is basically how much we repel, right? The repulsion from the track, and this attraction, which I'm calling F down, right? The force down, which kind of attracts, like this magnet that attracts the ship down to the track. Right. So let's think about that. I think that we should start by considering what we mean by the track base, right? So given that we have the sections, right? So I'm highlighting one section here already. Do you see this magenta color? This is one section, but our section has several faces, right? So this is one face, and this is another face, another face, another face, another face here on the left. And each face of our section, right, of our track, it comes already with a normal pre-calculated, which is a great thing. We don't have to compute this normal. In the file, it comes already with this normal vector per face. And this is the idea, right? The normal vector is this vector that is perpendicular to the face plane that we have. So it is basically forming an angle of 90 degrees. It is perpendicular to this face plane that we have. This one is perpendicular to this face. Do you see how it is pointing outside the section face? So now we're going to have all these normals per face. And if we look here in our code, I think in our track.c, we are loading already. Whenever we load the track faces, I think we are loading the normal. There we go. So for all the faces of my section, I am loading already the face normal, X, Y, and Z. So this is coming from the file. We already have this per face. So that's good news, right? Knowing that each one of these faces of the section of our track, they have that perpendicular, that normal that is pointing outside the track, right, in the direction of the track. I think we have to start thinking about this. First of all, what I'm really interested in right now is a force that is pointing in the direction of the normal, but I just want to consider the normal of the base sections, right, the base faces. So everything that is track base, that has that flag, these are the ones that I want to consider, because think about like the nature of our track. Our track, it goes right around the map, but if I turn, if I go, everything that I do with my track, I want that normal to point in the direction of the base, right? It has to point considering the base face of the track. So you know what I'm going to do? I'm going to make a judgment call, and I am thinking about having, and I'm going to create something called the section normal, which is going to be one of these normals from the base face. So see if you agree with me. Right here, whenever we are loading our section, right in our track.c, we have a function called load track sections that reads from the file. And remember how we are loading the section face start, number of faces. I think my section has an extra vector right here. I think I already added. I have something called s vector normal, but this thing right here is not being loaded from the file. So I'm going to have to manually load the section normal, what I'm calling the section, right? This big section normal, which is going to be based on all these faces of the section. But I want to consider only the track base faces. So let's just think about that. See if you agree with me. In my track.c, after I load all this information about the section, right here, after I'm done, I am going to load the track section normal vector based on the section faces, right? Only track base faces. Do you agree? So to respect everyone's time, I'm going to paste here already what I think is the correct answer to that. So after I load all the section, I am going to, I have a for loop, and then I have a j index here. I am going to go from 0 until the section's number of faces, right? So how many faces this section has, j++. So for each one of the faces of this section, I am going to initialize this face object using that pointer arithmetic technique that we learned. Remember, we go from track faces, this is the base address of the faces, plus we offset by the sections I face start, so we have the start face, plus j. So this goes to the correct face of that section. We go and we initialize this pointer to the correct face of that buffer of faces that we have. And then face per face, if this face that I just loaded flags and face track base, so here I only want to consider the faces that are face track base, right? The base of the track. If I found a face that is the base of the track, I'm going to say track sections of I normal, so I'm going to load this normal of the entire section as the face normal. So it's going to be the normal of that face, which happens to be a track base. And I even wrote here, we assume that the section normal is the same as the normal of the base face of the track, right? So that is exactly what we're doing. We're going face per face of that section, looking for only those which are base, and then as soon as we found something, we go and we load that base normal. We load that and say that that normal pointing up, let's say, is the normal of the entire section. So each section is going to have one big normal vector, which is going to be per section, right? Cool. So now that we loaded this thing right here, look, how about we draw a line pointing in the direction of the normal? I think it's going to be super cool for us to see per section, what is that normal vector per section, right? Where is it pointing at? So in the next lecture, I'm going to just quickly draw a little line that goes, let's say, from the center of the section pointing in the direction of this normal vector. So we can actually see what these normals look like in our map, right, in our track. So let's just quickly go ahead and do that in the next lecture. I just want to draw these normal vectors in our display.